We're given traffic flow as a rate in the problem, and so the traffic flow, which is F, so F of t is a rate equation. We're looking for how many cars actually pass through the intersection, so that's going to be the antiderivative of the rate, giving our answer as a whole number, looking over the time period of 30 minutes. So the number of cars that pass through the intersection is equal to the integral from 0 to 30 of the F of t dt equation. So using a calculator, type in the F of t equation. And the graph doesn't seem to appear, but if we just change the window to fit, we can see the graph. And analyzing the graph is the integral from 0 to 30. Then the answer, expanding it out to 2474, rounding to the whole number of cars. To find out if the traffic flow is going to be increasing or decreasing, we have to look, is f of t going to be increasing, or is f of t going to be decreasing? And that's at time is equal to 7. So that means we have to think about when f prime of 7 is going to be positive, or f prime of 7 is going to be negative. So to find f prime of 7, off the graph, analyze the graph, dy dx at the number 7, then expanding out to see more decimal places. So f prime of 7 is negative 1.873. So the traffic flow is decreasing at time is equal to 7 because f prime at 7 is negative. Looking for the average value is 1 over b minus a, the integral from a to b of the function. The function is the traffic flow, which was f of t. And we're looking on the interval from 10 to 15, so that's our a and our b, and don't forget the units. So the average value of the traffic flow is 1 over 15 minus 10, the integral from 10 to 15 of the f of t dt equation. In the calculator, the graph calculator screen, using that stored function f1, and the answer is 81.899 for our units. The 1 over b minus a is the 1 over the minutes, and the integral from a to b we know from part A is just cars, so our units are going to be cars per minute. Then for the average rate of change, that's f of b minus f of a over b minus a, with our function being that traffic flow, which was the f of t, and we're looking on the interval from a to b of 10 to 15, so the average rate of change is f of 15 minus f of 10 over 15 minus 10. Again, using the stored function f1 in the calculator to get the value of 1.518. To look at our units, the numerator is cars per minute, the denominator is minutes, so our units are cars per minute squared.